I'm Don Mockles, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 15, for the week of April 15th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. What's up in the sky this week? As our week begins on Wednesday, April 15th, the moon is 1 day past third quarter, so for the next week, we'll be seeing an ever smaller crescent in the morning sky. The moon is at new phase on April 22nd. On the morning of April 15th, you can see the moon passing south of Saturn and then Mars. It has already moved past Jupiter. The planet Venus still dominates our evening sky. It's moving towards a position between us and the sun, and will soon become a crescent phase. Both Mercury and Venus, our inner planets, go through phases, as does the moon. Venus is growing larger in size. It's getting closer to us. It's presently 48 million miles away. And when it's between the sun and us, and actually it'll be just north of the sun on June 3rd, it will be 27 million miles from us. It might seem that for all winter, Venus has been hanging out there in our evening sky, a common fixture. Every night, there it is. Well, that's about to change, and it will change quickly. Over the next 5 weeks, Venus will begin its disappearing act, and each night it will be lower in our western sky until by May 25th, 5 weeks from now, you'll not be able to see Venus in the evening sky. After it passes near the sun on June 3rd, and this is called inferior conjunction, Venus will technically be in our morning sky, becoming visible there by the third week of June. Speaking of disappearing act, over the next few weeks, the constellation Orion will be disappearing in your western evening sky. In the northern hemisphere, this happens quickly. 1 week it is there, the next week it's gone. This is why. The sun is moving north, and so each evening twilight in the northern hemisphere begins a minute or two later each night. Meanwhile, as always, the stars set 4 minutes later each night. So if you go out at twilight each night and look west, both factors add together, and the stars are not just 1 degree lower in the sky caused by the 4-minute drift, but more like 1.3 to 1.5 degrees lower in the sky because you're going out later in the night at twilight. So Orion and all the western sky seems to slip rather quickly into the west, while the eastern sky, the constellations seem to shoot up more rapidly. I've never seen this discussed before, so I thought I would mention something that I've noticed and maybe you have too. The International Space Station is visible depending upon your location. For the next week, those north of about 30 degrees north will not see it. So sorry, Denmark, Sweden, Great Britain, Germany, France, most of the continental U.S. Take the week off from trying to see the International Space Station. Those living south of 30 degrees north and as far south of the equator will see it in their morning sky on some of those nights. That's Mexico City and India. Get up in the morning. Giving you the warning. Those south of the equator will see it in their evening sky on most nights. So Australia, New Zealand, Argentina, you'll see it in the evenings. To determine where it will be in your sky, you can go to the website heavens-above.com and enter your location, then click on ISS. Last week, I suggested we look at the spacecraft headed toward Mercury, BP Colombo. I went out to see it, and that was great. I hope you did too. Meteor showers. My first astronomical interest was meteors, also known as shooting stars or falling stars. That was my entryway into astronomy when I was about 8 years old. A meteor is a particle that has been traveling through space that hits our atmosphere, producing heat and light through friction and chemical reactions. On any clear night, generally, a few meteors can be seen every hour. A meteor shower is an organized group of meteors hitting our atmosphere, all coming from the same direction and from the same source. Looking up, the meteors appear to originate from a radiant, like if you open an umbrella and hold it over your head. All the ribs seem to originate from the center and run out to the edges, or something like the spokes of a wheel. So how did all these meteors get organized into a group? Well, they are particles from comets. Comet trails, not tails, but trails. And these comets are generally periodic comets, those visiting the solar vicinity on a regular basis, leaving material with each passage. As the comets travel through space, these tiny particles disperse from the comet nucleus and coma, and they form a path along the comet's orbit. There's hundreds of these comet trails in space, but they matter to us only when our Earth intersects with one of these trails. Then, bam, we get hit by these particles as we travel at 18.6 miles per second through the comet trail. The meteors appear to come from a radiant, determined by our Earth's motion and the location and motion of the comet particles. That radiant in the sky is usually named after the constellation or star from which the meteors appear to radiate. However, if you go out to watch a meteor shower, you don't need to stare at the radiant. It's probably better to position yourself so that you're facing 45 degrees to the left or right of the radiant and about 45 degrees high in the sky. If the radiant is nearly overhead, you can lie on your back and try to stay awake. These meteor showers occur each year on about the same night, and it would do good to learn those dates and locations. Often, you will see the ZHR displayed on literature about the showers. ZHR is known as a Zenith hourly rate, the number of meteors that one can expect to see under ideal conditions, such as dark skies and the radiant being overhead, which is where we get the zenith and the zenith hourly rate, and at the exact time when the activity peaks. Now, this is ideal. So if a shower is said to give you a zenith hourly rate of 60 meteors per hour, expect a little bit less than that. As in life, nothing is ideal. Our next meteor shower is called the Lyrids, named after the constellation Lyra. The peak of the shower is the night of April 21st and 22nd, but some of those meteors can be seen a couple nights before and after. The material for this meteor shower is said to come from Comet Thatcher. That was discovered in 1861, and it has a 415-year orbital period. This meteor shower is one of the oldest ones observed. It's been observed since 687 BC. An oddity about this meteor shower is that every 60 years, our planets line up to deliver us a denser stream. That is, the gravity of the major planets can twist the stream somewhat. That last happened in 1982 when we had a ZHR of 90. That's expected to occur again in the year 2042. The constellation Lyra rises now in the evening twilight. The star Vega is that bright object in your northeastern sky about an hour after evening twilight, and it is in the sky all night long, reaching about overhead from mid-northern latitudes. Yeah, that is Zenith, near morning twilight. That is the best time to see the meteors, in the morning. ZHR is about 10 meteors per hour, with some brighter ones known as fireballs visible from time to time. The constellation Lyra is identified on podcast 15, map number 1. So the best time to see this shower is Monday, Tuesday, Wednesday, April 20th, 21st, 22nd, preferably in the morning or anyway, at least after midnight. And if you had to choose one night, try for Tuesday, April 21st. We will have good moon conditions because there's no moon in the sky those nights. Now let's talk for a few minutes about comets. Comet 2019 Y4 Atlas is not doing very well. Yes, it brightened rapidly in March, and it raised hopes it could become a very bright comet. As reported last week, this brightness decreased in early April, and by the second week of April, that is this past week, there was a growing evidence that it's disintegrating as the nucleus appears to be both breaking up and falling apart. Breaking up and falling apart, something not good for both relationships and for comets. Comets are unpredictable. We've covered that, but it's worth repeating with every comet. And every comet is different. The comets most likely to disintegrate are those that go close to the sun. Those comets are also the ones, if they behave according to the laws that many comets follow, that can become the brightest and the most spectacular comets. I discovered my first comet in 1978, my second in 1985, my third in 1986, and my fourth in 1988. Two of my first four comets, the ones found in 1985 and 1988, disintegrated as they went around the sun. Both were discovered in the morning sky. One went 9 times closer to the sun than we are. The other one went 6 times closer to the sun. Both were expected to put on a good show. Both failed to produce. The one I found in 1985, from the time I found it until it disintegrated, took less time than it took for me to find it, which was 1,742 hours. I thought, what's up with this? No one has half of their comets disintegrate. For me, that was the end of disintegrating comets. All the ones I've found since then have survived, and 2 of them return every 5.3 years. Although I should add that my second periodic comet, P141, has split a few times, but so far has not disintegrated. It will return to our neighborhood later this year, and we'll see what we will get. I'm not saying to not look for Comet Atlas. It still is there, but the prognosis is that it will probably dim and fizzle out, but that's not a sure thing. Use podcast 15, map number 4, to locate Comet Atlas in the evening northwestern sky. Now the tick marks are for 0-hour universal time. Translate that to your time, and then you'll know where it is in the sky. On that map, I have also plotted 2 other comets. Both are in the magnitude 8 to 9 range, and they're all in the same area. One is Comet 2017 T2 Pan-STARRS, which we were observing earlier in the year. The other is another Comet Atlas, Comet C2019Y1 Atlas, which had been a difficult object in the northwestern sky, fairly close to the horizon, but it has now moved to a more accessible part of the northern polar region, so you can give all 3 a try. There is a new comet discovered on images taken by the SOHO satellite using what's known as the SWAN images, SWAN. This comet is in the southern morning sky. It's magnitude 8 or 9, and it's slowly headed north. The official name is C2020F8 SWAN. We will discuss it next week, and by then we'll know if it is bright because of a recent outburst, or if it will sustain its brightness for a while. This week we're going to learn the constellation Leo. It is labeled in podcast 15 on both maps 1 and 2. It's near the center of map number 1, meaning it's nearly overhead. Leo the lion actually looks like its namesake, a big lion up there in the sky. It's a zodiac constellation, meaning the sun, moon, and planets travel through this region. Its brightest star is Regulus. That's a blue-white star, the 21st brightest star in the sky, 79 light years away. This star marks the beginning of a backwards question mark and represents the front part of the lion. At the other end, that is the eastern end of the constellation, we find Denebola, 35 light years away, and the 59th brightest star in the sky. Denebola is from the Arabic language and it means the lion's tail, as it marks the hindquarters of Leo. The Milky Way is nowhere near this area, and without our own dust obscuring the background objects, we see a lot of galaxies in this region. Our binocular object this week is a diffuse nebula known as M78. Before it disappears in the west, let's take a final look at the constellation Orion, specifically the belt of Orion and the diffuse nebula M78. This is plotted on podcast 15, map number 3, which you can get from my website. There is a lot to see in this area, many nebula, but let's start with the 3 stars in the belt. They are blue hot stars, and the span from one end to the other is 2.7 degrees. Through almost any binoculars, all 3 stars should fit in the same field of view. If your field of view is 7 degrees, these stars that span 2.7 degrees should fit right near the center. Under dark skies, you might see some nebulosity near the left eastward star. One of my earliest memories of the dark night sky was viewing these 3 stars through my dad's 7x50 binoculars in early 1963. Below the belt is a fabulous Orion Nebula M42 and M43. Now for M78. From the easternmost star, go north and slightly east 2.5 degrees. M78 is a reflection nebula, meaning that light from some nearby stars illuminate the dust and gas, similar to a street light surrounded by fog. M78 is 1,600 light years away. With our telescopes, we'll be going after some galaxies this week. With no moon in the sky, we'll look at 3 Messier galaxies. They are in the center of Leo, and they are M95, 96, and M105. They're plotted on podcast 15, map number 2. M95 and M96 are less than a degree from each other. M95 is a barred spiral galaxy about magnitude 9 and moderately elongated. M96 is a spiral galaxy of about the same brightness and magnitude. They are about 30 million light years away from us. North of M96 by less than a degree, we find M105, which is an elliptical galaxy at about the same brightness and distance as M95 and M96. Nearby M105 is a slightly fainter galaxy that was not noted by Charles Messier. It's known as 3384. Now for fun with the Messier Marathon. The Messier Marathon can be done any time of the year. With the new moon approaching, what does this month offer? Forget about getting the galaxies M77, M74, and M33. They have already set, so you'll not be able to see them. The Andromeda Galaxy can best be seen in the morning sky, as can M52 and M103 if necessary. In the evening, start with M79 in the south, catching it before it sets. then M76, 34, and M45 up north. Then head back south for objects near Orion and Canis Major before going north again for Taurus, Auriga, and the Gemini objects. The morning sky is easier to cover than it was during the March Messier Marathon, but add the Andromeda galaxies M31, 32, and 110 to your morning list. So at this time of year, you would probably at the most be able to see 107 of the 110 Messier objects in one night. I want to share a little bit about comet hunting in the Santa Cruz mountain range from a location known as Loma Prieta Mountain. The Santa Cruz mountain range is south of San Jose and Silicon Valley and north of the Santa Cruz area. That was my astronomical place from 1976 through 1990. It was from there that I discovered 3 of my first 4 comets. Comet number 2 was found from the Riverside Telescope Makers Conference in Big Bear, California in 1985. But the other 3 comets found in 1978, 86, and 88 were all found from Loma Prieta. At Loma Prieta, I spent 4,000 hours comet hunting, spread out over 15 years and 1,600 sessions. This location became so much part of me. I grew so fond of this area that on several occasions I told my wife I wanted to be buried there when I die. In the years since, that thought has evolved more just into simple cremation. Loma Prieta, which is spelled Loma and then Prieta, is Spanish for dark hill. The peak is 3,790 feet high, which is 1,160 meters. And I've been to the summit where they have a transmitting towers, but I've been there only once, and that was to drive a drunken employee to his workplace there. But that's another story for next week. You can get to it by taking Highway 17 south from San Jose, California, exit at Summit Road, and take that to Highland Way, to Mount Baki Road, to Loma Prieta Way. I drove that path 1,600 times. Loma Prieta also became the name for the October 17, 1989 earthquake that hit the San Francisco Bay Area. But the epicenter is south of the mountain in the forest of Nisene Marks State Park, 10 miles south. I hate earthquakes, and I'm disappointed they named an earthquake after my favorite mountain. But when you say Loma Prieta today, most people think of the earthquake. There's also a rock group called Loma Prieta. I would set up my telescope or large homemade binoculars along the side of the road at about the 3,300-foot elevation. There is an area where the road is just a bit wider with a drop-off to the east. Horizons to the east and south and even the west are low. It was and still is a dirt road, only now they have constructed a short guardrail along the west side of the road to keep four-wheelers out. It was here that I lived out many of my early comet hunting experiences. This is how I found this location. My brother passed away on March 2nd, 1976 in an avalanche at the Alpine Meadows Ski Resort. This was a shock to all of us and devastating. At the time, he and I were living with my parents in our house in Concord, California. A week after the funeral, I received an offer to interview at an eyeglass optical lab in San Jose, California. I remember very well going to my parents and saying, "Hey, I have this job opportunity in San Jose. And if I take it, I'll be moving out of the house. And you've just lost David, and now you'll be losing me. Is that okay?" And they said, "Go ahead. Go interview, take the job. You do have a life to live." And they said they could handle my leaving. So I did, and I got the job. The first 2 weeks I lived in Santa Cruz, south of the mountain range, with my sister. Then I got a cottage in Los Gatos, north of the mountain range. I was in my second year of comet hunting, using my 10-inch f3.8 reflector on a pipe mount. I was now used to commuting to comet hunting sites, so I was both mobile and portable. I was grieving the loss of my brother. I was depressed and had insomnia and high energy, kind of a mania phase, like a restlessness. These things are a good combination for comet hunting. So on moonless nights, I would go comet hunting, mostly in the morning. I would take off with all my telescope equipment, sometimes even when it was cloudy, and drive the mountain roads looking for observing sites, listening to the radio. I set up a few nights at Rodeo Gulch Road, then Vine Hill Road, Weaver Road, and finally Loma Prieta. The way I found Loma Prieta was that on May 9th, 1976, it was foggy at my usual location, so I found a mountain road and just kept going up and up until I got above the fog. When I got above the fog, I was at Loma Prieta. It was such a good site that I kept coming back. In 1974, I built an observing chair out of a dining room table chair. It had a wood seat and wood piece on top of the chair back. Both were carpeted, so I could sit high up or I could sit low on the seat and observe. That went with me everywhere, and I loaded it into my car's front passenger seat. Eventually, I began leaving it at the Loma Prieta site, covering it with a couple plastic bags to keep rain off of it, and hiding it under a big bush about 50 yards to the northwest of my observing site. That way, I wouldn't have to haul it around with me all the time. The road that I set up on was not used much in the early morning hours, until about 6 a.m. when I would still be there in the winter, and some of those few residents living east of my ridge would commute past me on their way to work in San Jose. One morning, after I'd been there a few years, a resident stopped to talk and asked why I chose this particular location to observe from. I explained to him the astronomical advantages. He noted that this particular location had a history. Back in 1972, 4 years before I began going there, a serial killer named Edmund Kemper buried 2 of his victims about 50 yards to the northwest of here. After Kemper surrendered in April 1973, he took authorities to this burial site and the sites of each of his victims, which, by the way, also included Rodeo Gulch Road, and they retrieved the bodies and gave them proper burials. Look it up, Edmund Kemper. This never really bothered me. I'm not afraid of ghosts, but my only takeaway is that at one time, someone intent on evil parked his car right where I'm parked. This mountain, Loma Prieta, deserves better, and I hope my years of comet hunting and discoveries gave it the recognition it deserves. You have been listening to Looking Up with Don, podcast episode number 15 for April 15th, 2020. Once again, the related website for this podcast is donmachholz.com. That is spelled DonMachholz.com, 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky, our weekly check on Comet Atlas, look at one of the most famous double stars in the sky, and more adventures from Loma Prieta. Thank you for listening. See the sky this week. I'll see you next week.